I had an interesting conversation with a homeowner the other day, and the question was, why would I ever need to dilute my pool or drain and dilute my pool? I thought, well, to me, the answer is obvious because I'm in the pool trade, but I thought it would be worth doing an episode. So this is episode 47. Welcome back. 47 of the Rule Your Pool podcast. I'm your host, Eric Knight, doing this one alone from my studio. Couldn't get Jared, couldn't get Joe. And to be honest with you, I didn't even ask them this time. This is more of a spur-of-the-moment episode because it's on my mind, it's fresh, and I just wanted to talk about it and get it recorded. And everybody's busy right now anyway. We just had Thanksgiving, we're coming up on Christmas, and then we've got trade show season from the first week of January until basically the last week of March. If we don't get episodes recorded, you might forget about the Rule Your Pool podcast, and I just can't do that to you. So we're going to try to get a bunch of these episodes recorded and pre-record them so that you have something to listen to each week. And I think it'll be relevant throughout the winter time and the off season for most of the country, even though, the Sun Belt areas, they don't have an off season. They're working all year long. So in this episode 47, we're going to talk about draining and diluting, when and why you should do it.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
The first thing I'm going to say about dilution is it's not always the solution. That phrase, the solution to pollution is dilution. That comes from the HVAC world. That's not always the case in water chemistry. In fact, it's not always the case in the HVAC world either. Dilution's good usually if you're diluting with fresh air, or in this case, fresh water. But it's not always the best thing to do. All right? And when I got the question about, why would I ever drain and dilute my pool? Well, there's this concept of aged water or old water. And over time, you get an accumulation of things. I believe we did an episode on evaporation and accumulation, which really, we probably should have done this one as a follow-up to that, because accumulation happens when water alone leaves through evaporation. Evaporation doesn't take minerals and cyanuric acid and salt. It doesn't take those out. It only takes water. So those things will accumulate. And then you have to figure, okay, how much am I losing to evaporation? How much is being refilled? And you have to know your tap water. Let me rephrase. You don't have to know any of this stuff. You should have a pretty good idea of it. Because if you wanted to know what your dilution rate was, you could calculate it. It can be done. I'm not suggesting you go out and buy a lab coat and beakers, but it can be done. But what's important to know is your tap water chemistry of what's replacing whatever is lost. So with evaporation, you're losing pure water. Everything else stays behind. With dilution, you're losing whole water. You're losing everything in it. You're bleeding it off through a longer backwash cycle, or you're deliberately draining it, or you're pumping it out when you're vacuuming to waste or something like that. You're taking all of the elements that are in that water with it, and based on how much you remove compared to the total volume, that's the percentage of dilution. And then whatever fills that void, if it's tap water, if you know what that tap water chemistry is, you're going to know what comes back in. So for instance, if I got a water bottle on my desk I'm looking at, if you've got a water bottle and that full water bottle has 400 parts per million calcium in it. If you drank half that bottle, the bottom half, that's still in the bottle, of course, the bottom half still has 400 parts per million of calcium because you took whole water out of the equation. Now, if you take that same bottle, full bottle, and put it into a pot and boil it, and you boil half of it away, the parts per million of calcium in that half of water is going to be 800 because only pure water left, but calcium didn't. So you actually double your calcium level. You double your TDS, whatever the TDS was for other factors. Now, if you go the other way and dilute it, so I drank half the bottle and then I refill it with the same, bottled water, this is a smart water, and I take another smart water and I refill it back up, I'm going to be right back at 400 because my refill water, in this case, in this analogy, your pool would be tap water, is the exact same chemistry that was in the bottle in the first place. So there's no difference. It's a net zero. So it just goes back to 400. Nothing changes. But what if I don't put the same 400 part per million calcium water in there? What if my fill water is 0 parts per million? Maybe it's on a softener. Or maybe it's rain and snow that get in your pool that have 0 calcium in it. Well, if I had half that bottle and it's replaced with rainwater, I don't have 400 parts per million anymore, because when it gets filled with rainwater, my TDS, including calcium, just got cut in half because I've diluted it down. So what went from 400 is now down to 200 parts per million in the full bottle. This analogy of the water bottle has helped me. I don't know if it's helping you, honestly, but go in my left ear and out my right. It makes sense to me. This is how I visualize it. So I just think of the water bottle. When someone's explaining a chemistry problem to me in a backyard or something, I try to think of, okay, how did this happen? Where could the chemistry have gone? It's most noticeable in pools that close with mesh covers or no cover at all, because, they're not being regularly treated every week, and there's a lot of rain and snow in the colder areas. Or if you're in South Florida, you just get a lot of rain. So the point is, if you think about what is replacing the water that was removed, and you think about how the water was removed in the first place, it either evaporated or it was physically removed, either drained, pumped out, or splashed out by swimmers. All of those are methods of dilution. Splash out counts too. So if you evaporate, that's not dilution, because that's going to accumulate everything else. That's just the loss of water, and then you replace it with, tap water. If it is splash out and you replace it with tap water, there's a different delta there. So to answer the question of why would you ever dilute your pool, it's not so much about TDS being high or anything like that. It's about what's in that TDS. Specifically, the two that drive people up a wall is high cyanuric acid and high calcium hardness. We'll start with cyanuric acid. That should be the obvious one, because that affects both sanitation and disinfection because of chlorine, and it affects the LSI. High CYA alone, regardless of your TDS, could be worth draining. Now, there are ways to reduce it. There are products out there, mixed results at best. I think it complicates things, but that's a conversation for another day. The most practical way to reduce CYA, hands down, drain and dilute. I almost published a blog on the Orenda website about this, and I just wanted it to be one sentence. I thought that would be kind of funny. How do you reduce CYA? Drain and dilute. Publish. That's pretty much the only practical way to do it. Now, you could do reverse osmosis. It's not available in every area, but reverse osmosis will take cyanuric acid out and everything else. So it might be a little costly, but in an area, a drought-stricken Southern California, that might be the best option for you, so that you don't have to violate any local rules and regulations. So it depends on where you are. So you could get rid of cyanuric acid that way. That would be worth draining and diluting alone. Calcium hardness is the other one. Now, we actually, as you know, we like higher levels of calcium hardness, but there is a certain point where it becomes a detriment. For instance, if you're in a very hot climate, let's say you're in Tucson, Arizona, or Phoenix, or Palm Springs, or something like that. Yeah, the evaporation rate is high. The air is dry. You're going to lose a lot of water quickly. High calcium hardness can lead to a faster scale line forming. It can be a mess, and maybe you don't want, 450 calcium or higher. Okay, makes sense to me. You want to lower that down, adjust your LSI with different parameters. Okay, I respect that. How are you going to lower that down? Well, you drain and dilute. There you go. If, getting back to the water bottle, if you drain half your pool, your calcium should be cut in half approximately. By the way, assuming you know how much half your pool is by looking at it, because pool shapes can be kind of wonky. But you get the idea. Same thing with CYA. If you have 100 CYA and you want to cut it to 50, which we would recommend, by the way, or lower, drain half your pool. And you don't have to do these things all at once. You can drain it, over several weeks. You can drain a couple inches here, a couple inches there, vacuum to waste there, extend your backwash cycles every week. You can do this over time. The other thing is you can let nature help you dilute it for you. I mentioned Palm Springs and Arizona for a reason because they don't get a lot of rain except for a very small part of the season. As opposed to South Florida, which gets rain, pretty much every week or every day sometimes for a quick 6-minute torrential thunderstorm. I don't know if you've ever been to South Florida, but I have. At 3 p.m., it's like, oh, I don't need my watch because here comes the thunderstorm. It must be 3 p.m. That is going to dilute water down too, but with distilled water. No calcium, no CYA, no nothing in it. So there's a big difference between tap water refilling it, like maybe your pool has an autofill, but a lot of pools don't. And so they get the benefit of more rainwater. So if the water level goes down, rainwater comes in, somebody can have a more controlled way of refilling that pool. So just be thinking about that. And what I'll close here on is it's not about the TDS. Okay, there's been studies done, and I didn't do any of the experiments, but I've definitely done a lot of reading on TDS, and I have come to the conclusion that the TDS number itself is not nearly as significant as our industry textbooks would have you believe. Like for some reason, there's this parameter out there that says you shouldn't have more than 1,500 parts per million of TDS over the tap water. Right. But a salt pool needs 3,000 to 3,500 in just salt to make the salt system work. So that's kosher, that's cool, but we can't have 1,500 in another pool? What's the deal? Is it because of chlorination? Is it because of conductivity? No, it's not. I actually don't know what it's for. I've looked into this. I've asked people. I still have not received a good answer. So what I did was I did a bunch of research in other industries. What do drinking water people think? Wastewater, that kind of thing, agriculture. TDS in general is not really that big of a threat because it's dissolved solids. People might think that cloudy water is from high TDS. No. In fact, we had an old blog that was one of the things that we listed because that's what a textbook said. But no, it's dissolved solids. They're invisible. You can't see them. It depends on what those solids are. Like I said, cyanuric acid, high calcium. If it's preventing you from maintaining LSI balance or proper disinfection, yes, drain and dilute. Get your chemistry in order. It's better to drain and dilute than to throw more chemicals into that cocktail and try to correct things. You might just want to simplify things. It might make it a lot easier for you. And of course, we're minimalists here at Orenda. And in order for you to rule your pool, let's get as much crud out of the way and simplify things. So you don't always have to drain and dilute, especially not if it's just high TDS. If you have liquid chlorine, 1 gallon of liquid chlorine puts in, I think it's 17 parts per million of TDS in 10,000 gallons of water. 15 parts of that 17, by the way, is pure salt. So your salt's going to climb, but is that really that big of a deal? Because conductivity in a salt pool is excellent. In fact, you need enough salinity for that conductivity to happen. And by the way, 3,000-4,000 TDS, that is something that people might panic over. Oh, that's too much. I'll have cloudy water. Well, have you ever been to the tropics? I mean, the ocean can be crystal clear like glass. And the ocean is like 50,000 parts per million of salt alone, let alone all the other minerals. Depending on the source, 30,000, 50,000. I don't know exactly what it is. I'm not an ocean biologist. But the point is, the swimming pool is remarkably pure compared to natural water, like rivers, lakes, ponds, and the ocean. It has very low TDS, even if it's a salt pool. So I'm not concerned about TDS. We're not at Orenda. The research that we show is not about the TDS. It's about certain elements in it. Cyanuric acid in particular, maybe calcium hardness, metals. Metals can be very high, although there's better ways to get metals out that you might not have to drain and dilute. But in general, if you just have an accumulation of stuff you don't want, that's when you would drain and dilute or let Mother Nature handle it. I'll close on this. For winterizing pools, we've talked in a few episodes and several blogs about the type of cover you have if you do winterize pools. Solid covers prevent this sort of dilution, like safety covers, that automatic covers, and anything that stops rain and snow from getting in. But if you have a mesh cover or no cover, that's outstanding. You're going to get plenty of dilution. But that means that you need to account for that when you winterize your pool in the fall, because you're going to get dilution. You better have enough in the tank so that, if you winterize at 500 or 550 calcium, which we do recommend in a freezing area, when you open up in April, it could be 300 something or low 400s. What you don't want is to go in with not enough calcium and then have that number cut in half again because of all the rain and snow you got. So just keep that in mind. Dilution is a good thing. It's not always the solution, but it is the most practical answer to certain things like high CYA, high calcium hardness, etc. I hope this does help. Maybe that was a narrow question. I have had it before, but certainly it was pertinent. And this has been episode 47 of the Rule Your Pool podcast. I'm your host, Eric Knight. I hope to get Joe and Jared on future episodes here that we're going to try to record before trade show season and maybe get another one in before Christmas. If you don't hear from us before then, have a very happy holiday season. I hope you get to spend it with your family and loved ones. Take care of yourselves and enjoy ruling your pool, even if it's in the off season.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.